Hello and welcome to USMA Orgo. We are now getting into Chapter 2. So Chapter 2 is entitled Families of Carbon Compounds. This is getting exciting because we're getting into how we categorize and identify organic molecules. And we can also find out how we can use some instrumentation such as IR to give us information about different molecules. So let's get started. So this is just a snapshot of a bunch of different molecules you'll see in your book, and you can take a look at them, but all of them have different functional groups that we're going to learn throughout the semester. And if you do a quick look, you can see that that organic chemistry is involved in everything around us, from things that we smell and eat to things that make us make our vision work, to different neurotransmitters, to DNA backbones, the cholesterol. So everything around you is pretty much organic chemistry. So it's really important that we understand the different functional groups in organic chemistry and how they interact with each other. So you're going to see these functional groups in a chart here, and the most exciting part of all this is that functional groups is where the chemistry happens. So all the chemistry we're going to talk about from here on out is going to happen at a functional group. And so as we go through organic chemistry, we'll study each of these functional groups in detail. But for now, you should be able to pick these out on a molecule. So all these are important functional groups that you should pay attention to and understand. So we have the different types of single and multiple bonds. So rings, we have halogens, alcohols, phenols, ethers, and then amines where you have nitrogens. You have aldehydes where you have carbonyls and a hydrogen. You have a ketone that has carbonyl with no hydrogens. You have a carboxylic acid, carbonyl, and an alcohol. An ester with the carbonyl connected to an oxygen connected to another carbon. An amide bonds is a carbonyl and a nitrogen bond, and then nitriles. So again, as we go through this, you should be familiar with these functional groups and be able to point them out, and then we'll learn about each one individually as we go along. So next is, now that we start seeing these functional groups in molecules, is how they interact with each other. So we have different types of interactions, and in Chapter 1 we talked about compounds that were ionically bonded. So now we're going to go and dig a little deeper. So when there's a difference in electronegativity between two atoms, you're going to get a polar covalent bond. So you're going to create a pole because you're going to have one part of the molecule attracting the electrons stronger than the other. So for example, if we have hydrogen chloride, or what we call hydrochloric acid, you're going to have a dipole moment in this direction, which when we draw dipole moments, you have a positive over the most positive sign, and then the arrow going towards the area where there's more electrons. And so really what that's describing to us is that the electrons shared in this bond here is going to be unequal. So because the chlorine has a higher electronegativity, you're going to have a lot more electron density than you're going to have around the hydrogen, because that electronegativity difference. And then when you have multiple atoms attached to a compound, or an atom that has different dipole moments, then we can have the whole molecule can be polar or nonpolar. So for example, if you had a carbon that had a chlorine and it was attached to 3 other hydrogens, and we draw the dipole moments here, they're all going to be in this direction. So in general, this molecule is going to have a dipole moment, or excuse me, it's going to be polar, and it's going to have more electron density around the chlorine end of the molecule than you are going to have on the hydrogen end of the molecule. Another thing we get into in this chapter is talking about molecules with functional groups and describing them as primary, secondary, tertiary. So when we do that, that's based on the carbon that the functional group is attached to. So as you can see below here, we have a primary carbon, secondary carbon, and tertiary carbon. Each one has, so the primary has 1 carbon attached, the secondary has 2 carbons attached, tertiary has 3 carbons attached to that carbon that's attached to the halogen. So once we understand those, then we can start talking about how molecules interact with each other. So if we have different polar compounds or ionic compounds or ions, we can have different forces between them, and those are considered intermolecular forces. We're going to show you on the next page the different intermolecular forces. But those intermolecular forces are what drive the changes or differences in melting point, boiling point, and solubility. So these different attractive forces that you see here are responsible for how high or how low a boiling point is, because you have the different interactions of the different species with each other. And then the last thing we'll talk about is infrared spectroscopy. So here you see a diagram of IR, and you can read more about that in your book. They produce a spectrum. That spectrum represents how atoms in a molecule interact with each other. So whether you have a spring-like stretching, or you have symmetric stretching here, or asymmetric stretching, or in the plane or out of the plane, those all give you different spectra peaks or absorbances on a spectrum. And in your RDC you have these different functional groups along with where they typically show up. So for example, C triple bond C usually shows up around between 2100 and 2260, and there's more characteristic absorbances for those functional groups there. So just as a quick example, you can see this molecule here. You have a nitrogen and you have a bunch of double bonds or a ring. So you can actually see characteristic absorbances for that NH bond, for the aromatic CHs, and say for the ring stretch between the carbon-carbon bond. Those stretches are depicted below, but the important thing is you can look on your chart, see where those absorbances are, and then match them up to describe what type of functional groups are present on this molecule. You can also look at this and determine what functional groups aren't present on your molecule, and that gives you information about what you're dealing with. So finally, I want to point to the end of the chapter, page 103 again, where it has a good summary, and it kind of gives you a good flow chart to show you the functional groups, give us information about reactions, help us predict physical properties, and give us characteristics. And then those, as you go down, deal with the different characteristics of the molecule. And again, if you have any of these portions that you're not clear on, it's a good time to go back to those sections and review them before class. All right, have a good day. See you.